Hi Math 2E. This is our 9 through 14 review and some useful formulas for this review as our slope formula, the difference in the y values over the difference in the x values, using our slope-intercept form of the equation, y equals mx plus b, and then one of the formulas we learned this year, our point slope formula. This is the one that has our y minus our k equals m times, that's our slope, x minus our h. These formulas are also on a formula sheet that you'll find in the locker. You're welcome to print this and use it as a reference. We'll be using all of these formulas on this sheet today to do our 9 through 14 review. So for question 1, it says select all the equations that represent the graph shown. So for example, in this graph, I need to figure out the slope, and I can do that either with the slope formula or by using a slope triangle since I have the picture here. And it looks like my slope is what, 3/2? And so I know my y-intercept is -3, so that's my y-intercept. And I can use that to write the slope-intercept form of my equation, and I can pick it out of my choices. Once I have that, I also can use my point-slope formula to write another equation. I happen to see that, for example, the point for 3 is on my line. So I know my line has a slope of 3/2, and the point for 3 is on my line. So let's use my point slope formula. Y minus my y value equals the slope times x minus my x value. So it looks like also y minus 3 equals 3/2, x minus 4 is on my line. So lastly, A is a possible choice for me. There's different things you can do, but when you have your slope-intercept form of the equation, why don't you multiply both sides by 2? That will clear out your denominators. And then rearrange your equation with algebra to see if it's also equal to 3x minus 2y equals 6. That work is in the locker. So then a line with slope 3/2 passes through this point, and it wants to know if these points are on the line. So your first thing you have to do is write the equation of your line. So you're given a point, and you're given the slope. So I can write the equation, y minus 3 equals 3/2 times x minus 1. And then to determine if 3/6 is on the line, I'll plug a 3 in for x and a 6 in for y, and I'll see if it makes my equation true. I'll plug a 0 in for x, a 0 in for y. I'll see if it makes my equation true. And lastly, I'll do the same thing with 13 and 22, and I'll see if it makes my equation true. So then, number 3 at this point, given a point and a slope, you should be able to write that equation based on numbers 1 and 2. The answers again are in the locker for you to double check. So number 4, select all equations that are parallel to this line. So to be parallel means that I have to have the same slope. So let's figure out what my slope needs to be. I could solve this equation for y. So I have, I'm going to subtract 2x over, so 5y equals -2x plus 8. I'm going to divide every term by 5 to isolate my y term. And it looks like the equation of my line is y equals -2/5 x plus 8/5. -2/5 is my slope. And so I'm looking at these lines over here to determine which lines have the slope of -2/5. Again, when I'm doing E, I'm going to need to solve that for y to determine what the slope is. So 5, write an equation of the line that passes through this point. So this is my point, and it's parallel to a line with this x-intercept and this y-intercept. This is identical to one of our practice problems in our workbook. I'm going to use the x-intercept and y-intercept, these 2 points, to determine the slope of that line. When I know the slope of this line, I know that the slope of the line I'm trying to write has the same slope because they're parallel, so they should have the same slope. Since I'm not given the graph, I'm going to use my slope formula. Slope formula is the difference in my y values divided by the difference in my x values. So for this problem, the difference in my y values would give me, for example, 0 minus 1, and the difference in my x values would be 3 minus 0. I can start with 0 or I can start with 1 in the numerator, but the denominator I have to start with the x coordinate that goes with the first y coordinate in the numerator. So that gives me a negative 1/3 for my slope. So I now have a slope and I now have a point, and I can write the equation of that line using the point slope formula. Okay, ladies and gentlemen, this is a very similar problem. The difference to this one, it says write an equation of a line perpendicular. So perpendicular is trying to talk to me about the type of slope I want. And I know perpendicular slopes are opposite. Sometimes in class I would say negative, but they're opposite reciprocals, if you remember. So in this case, I'm going to use the fact that I know the slope of my line is 4/3 to help me determine my perpendicular slope, which would be the reciprocal would make it 3/4, and the opposite sign here would make that a negative 3/4. So now I have my slope. And really, I could write any equation of any line that simply has this slope. So there are an infinite number of answers. You can literally make up anything you want. So for example, if I wanted to use the y-intercept form, I would have to have a slope of negative 3/4 x, and now I could have any y-intercept I wanted. I literally could write any number right there. That's an equation of a line that would be perpendicular to this one. I could also use my point slope formula if I'd rather. So I could have y minus any number I want. We'll say 1. I have to have a slope of negative 3/4, and then x plus or minus any number you want. That's also a line that would be perpendicular to this one because the slope is the negative reciprocal or opposite reciprocal. So in this case, number 7 is a little different. It does tell me it has to pass through the origin, so it has to go through 0, 0, and it has to be perpendicular to this line. So my slope, my perpendicular slope in this case, is going to be, this is negative 5/1. So let's do the reciprocal, that's 1/5, and the opposite would make it a positive. And so now I'm going to use the 1/5 and the 0, 0 in my point slope formula to write the equation of my line. So number 8 is also similar to a homework problem we did in class, or a practice problem in our workbook. It says write and sketch an equation for a line that's perpendicular to L. So again, there's infinite lines you can write. You first need to determine the slope of L. You can do that with a triangle, a slope triangle, for instance. And then you're going to need the perpendicular slope. And you can literally do any y-intercept you want with that perpendicular slope. So as you can visualize, we've got many, many lines going through line L. And then it says write and sketch an equation for a line that's parallel to L. Again, there's infinite answers for this. Once you have found the slope for L in the first part, now you can use any y-intercept you want, and you can create a line parallel to L. There's possible answers in the locker, and if you have questions on this, again, come to our Zoom office hours. I'm happy to help you more. So on number 9, it asks us to graph the equation of this circle and this line and determine where they intersect. This was a problem in our lesson, in our workbook. Maybe look at lesson 13 or 14. So anyways, you want to graph this. This is my center. My center, my circle is 1, -2, and my radius would be 5. So at 1, -2, and then I would go up 5. I would go right 5, left 5, down 5, and I'd pencil in a circle. And then y equals 2, this is a line. Remember, a y equals is a horizontal line at that number. So on the y-axis, I go to 2, and so I have this line right here. It should appear to intersect the circle you sketched in 2 places. So it might not be right on, but you'll know that the y value has to be 2. And so determine your 2 points, your maybe points. Mine are in the locker. And you're going to plug those points into the circle equation to see if it makes it true. And if that point makes it true, yep, it's on the circle as well as on the line. And if the point doesn't make it true, then it is not on the circle. So then it would not be where they intersect. So let's take a look at this next page. So this is lesson 14, and it wants us to show that a quadrilateral with these vertices is a parallelogram. So we did something similar to this in class where we had to graph it first. So you're going to put your 0, 0, which is A, on your graph, and then B is what, 1, 3, and then C is 0, 4, so 0, 4. And D is negative 1, 1. Okay, so I'm going to lightly sketch in my drawing, and it wants to know if this is a parallelogram. So notice this handy dandy box that was put on top of this worksheet for us. This particular parallelogram says that opposite sides have to be parallel. So we're going to use that for number 10. We're going to show opposite sides are are parallel. This means I need to show that they have the same slope. So I'm going to use the slope formula 4 times. So for instance, I want to find the slope of DC. This means slope, not measure. So I would go to my coordinates for D and my coordinates for C, and in the numerator I would subtract my y values. So let's say I decide to do 4 minus 0. Great. So, I'm sorry, it's 4 minus 1. I'm sorry. So 4 minus 1. And then in the denominator, I would subtract my x values. Since I begin with 4, I need to begin with 0. So 0 minus a negative 1. So 4 minus 1 is 3. And a negative 1 is a positive 1. So it looks like I'm getting a slope of positive 3. So now I would do a slope of the opposite side, which is AB. Yep, sorry, my B got lost up here. This is my B. So now I would do the slope of AB. What I'd like to see is if that is also equal to 3. If it is, I have just showed those two sides parallel. You'll do the same thing to side AD and the side CB. And again, you want to show that those slopes are the same. Once you've done that, if I could just bring over my answer key, once you've shown that your slopes of opposite sides are the same, you can state that this is your parallelogram. So that's how you can prove that your ABCD was a parallelogram. This problem, notice number 11 is really on the other side. So plot your 4 points of our rhombus. So our points of our rhombus are 0, 0, 5, 0, so over 5, 0, 3, 4, and 8, 4. So here's my rhombus. And I think it's helpful to write the coordinates in so you can use them. Oh, I think I went over too far. This is my 5, 0. Sorry, and that is 8, 4. Okay, sorry about that. Bad eyes. I'm sure none of you made that mistake. 3, 4, and 0, 0. So I'd like to prove that this is I'd like to show that it has to find the slope of the two diagonals. So if I could pencil in my diagonals, 1, 2, 3, right there, and this diagonal right here, you could label these if you wanted to. You could call this A, B, C, D. But what I want to do is I want to find the slope of AC, for instance, from 0, 0 to 8, 4. And then I want to find the slope from DB, or 3, 4 to 5, 0. And then once you find those slopes, it says, part B, what do the slopes tell you about the diagonals in this rhombus? So once you find your slope, for example, the slope of AC would be the difference in my y values, 4 minus 0, over the difference in my x values, 8 minus 0. Looks like I'm getting 1/2. You will get a different answer. It will not be 1/2 for the slope of BD. When you get that answer, compare your two slopes. That's question B. What do the two slopes tell you about the diagonals in a rhombus? And if you go back to the handy dandy diagram, It's the rhombus should have 4 congruent sides. And what you're finding here is something interesting about the slope of the two diagonals. And maybe you can kind of see it from the picture, but you're going to see something when you look at the two slopes. So that's A and B of that problem. C is a different problem. C is talking about a triangle formed by 0, 0, 4, 3, and negative 2, 11. So you will graph those points and you'll be drawing in a triangle. It then asks you to find the area of that triangle. Remember, the area of a triangle is 1/2 base times height. So it's important that this is a right triangle. You're going to show that it's a right triangle using slopes as well. Remember, perpendicular slopes, that would be your 90-degree angle, should have opposite reciprocal slopes. So in this case, once you sketch 0, 0, 4, 3, negative 2, 11, look at your sides, determine which two sides form your 90-degree angle, and then you're going to need to, just like I did here, you're going to need to find the slope of one side and the slope of the other side. You're going to be trying to show that those two slopes are opposite reciprocals, and in part C, that's how you can show the triangle formed is a right triangle. And then to find the area of the triangle that goes on, you need to know the lengths of those sides. I'd like to remind you of the distance formula. That was the difference in my x's squared plus the difference in my y values squared. And that's how I would figure out the distance. So for example, let's sketch this triangle 0, 0, 4, 3, kind of on top of itself there, and negative 2, 11. So if I could pencil this in, I've got this green triangle. I realize it's not perfect. This certainly looks like my 90-degree angle. And in part C, I probably have already calculated the slope of this line from negative 2, 11 to this coordinate 4, 3. And I've calculated the slope from 0, 0 to 4, 3, and I've shown that they're opposite reciprocals. That was part C. So for part D, what I need to do is I need to find the distance. I need to find the distance from the negative 2, 11 to the 4, 3. I want to know how long the side is. And then I also want to know the distance from 0, 0 to 4, 3. I'd like to know how long this side is. Once I know that, I can plug this number, this length, and this length into my 1/2 base times height. This would be my height. This would be my perpendicular base. And I can calculate the area of this triangle. So just a reminder of how to use the distance formula. The difference in my x's, it really doesn't matter which one you start with. The 2 or the 4 makes no difference because you're squaring them. And then the 11 minus 3 squared equals, in this case, the square root of negative 6 squared plus 11 minus 3 would be, what is that, 8 squared? I would need to get out my calculator and find the square root of 36 plus 64. We just found the longer side here to have a length of 10. So I would use the distance formula to find the length of my shorter side, the base right here. And then I would use the 10 and that distance, the distance from 0, 0 to 4, 3, inside my area formula. Area equals 1/2 base times height. And the rest of my work is in the locker. So let's look at our last question. It says a quadrilateral has these vertices. Prove that ABCD is a rectangle. So ladies and gentlemen, I would plot these and connect them. And then to prove that it's a rectangle, if you go back to the previous page, a rectangle has 4 right angles. Right angles are 90 degrees. They're formed by 2 lines that are perpendicular. So this again becomes a slope problem. You're trying to show that your sides have perpendicular slopes. Because if they have perpendicular slopes, then they are 90-degree angles, which are our right angles. And so in this problem, after you've plotted your rectangle, then you're going to find the slope between the two coordinates, the slope between two coordinates, the slope between two coordinates, and then your fourth side. And then you should be looking at your slopes, which will show that they're opposite reciprocals. Therefore, they're forming 90-degree angles, right angles, and it's a rectangle. Thank you so much. Bye.